All right, let's get back to the research review. Um, and so what I'm going to talk about today is Mcity's Autonomous Vehicle Safety Assessment Program. This is a topic I've been working on for the last 10 years or so, and has a lot, I think, has a lot of interest from outside as well in terms of how we assess the safety performance for autonomous vehicle. And this is not only a topic interesting to researchers, but also a topic has a lot of attention from the government agency, also the autonomous vehicle developers. As we all know, autonomous vehicle in the last 20 years has been heavily invested globally and being deployed right now. You can see from deployment from Waymo in San Francisco, Phoenix, Los Angeles, Austin, and other cities, and then several autonomous vehicle developers also deploying these in China, and then Way is also deploying this in Europe as well. So a lot of interest, a lot of money being invested in this. However, a recent survey, this is 2025, and AAA has a survey on the U.S. drivers. Is only 13% of U.S. drivers trust riding in the A-ways. That's really, really low. And but if you look at in terms of the self-reported safety performance for autonomous vehicles, and I listed a few companies, these are all coming from their either a blog or their paper or public available data, including Cruise, Waymo, and Tesla. And then looking at in terms of the accident rate per million miles of autonomous driving. And they all, the blue bar is what they think in terms of the human driver performance on accident rates. And then the orange bar is their autonomous vehicles safety performance. And then you can see they all better than what they think the human driving's in terms of safety performance. And the dash line over there also demonstrate from overall, from NHTSA perspective, what would be the average human drivers in the US. And you can see that some of these is much lower, and in particular from Tesla's report. Even with such a low or better performance reported by the autonomous vehicle companies, and the trust from the drivers and from the users is very, very low. And if you look at in terms of what's happening in the autonomous vehicle, there's really two sides of the stories. And most of the things is related with how we conquer really the long tail events. But if you really look into the long tail events, there's really two types of events that cannot be all have problems sometime for autonomous vehicle. One is a super, super challenging event, right? So something really bizarre happens, and then even human will have difficulty to handle this type of situation. So that's one. The other one is, which is more alarming and also damage to the trust, is these normal event from human driver perspective. In fact, one of the survey recently, it's actually the paper reported in Nature Communication, is that 94% of the accident involved with autonomous vehicle are really normal, under normal conditions. It's not a very bizarre, not a very challenging situations. It's these normal conditions sometimes autonomous vehicle cannot handle, and that really damage the trust for the safety of these vehicles. So that's also why the safety testing safety performance testing is really, really important. So if you look at in terms of the existing autonomous vehicle safety testing, there's really focusing on either these deterministic type of crash test, right? So we crash into a wall and see how the occupant's being protected. And really from autonomous vehicle perspective, the focus has been on functional safety. We look at it in terms of the hardware failures or the safety of intended functions, which is SOTIF, focusing on the software insufficiency. Under certain conditions, your perception algorithm cannot really see things clearly and things like that. And so all of these are really vehicle-centric methodology in terms of safety performance testing. However, now, if we want to deploy these vehicles in a large scale, we're not really talking about demonstration now. We're not talking about just one vehicle, two vehicles, three vehicles. We're talking about hundreds, thousands, tens of thousands of vehicles are being deployed. Now, under this type of situation, even low probability crash rate, when you multiply by tens of 5 or tens of 6, the probability become a lot higher. So for these large-scale real-world autonomous vehicle deployment, I want to mention 3 things. One is we want to ensure these autonomous vehicle safety performance is acceptable. Well, that come into what Greg has been discussed. How safe is safe enough? What is acceptable? And this need to be a community consensus, not going to be just Mcity or just a leading company saying, we have a good performance, but it's not acceptable to the community or to the society. Second, we want to be confident that when these vehicles being deployed, their impact to the traffic environment is acceptable. For example, if you have an autonomous vehicle overly conservative, then it becomes a hazard for other vehicles in the traffic flow as well. So it's not only just the safety performance of the ego autonomous vehicle, but how these vehicles impact traffic environment, particularly in terms of safety, become also very important. And the third thing is that we want to be able to discover the unknown, unsafe situations for autonomous vehicle as much as possible before we deploy these vehicles on the road. So if you look at these 3 things, the functional safety approach we've been focusing on from the industry perspective is not sufficient. It's not right now. It's not just a vehicle-centric approach that can help us for the deployment. We're not looking at a much larger scale. We're looking at how these vehicles really behave in a traffic environment, how they really impact the traffic environment. So that's why I think we really need a clearly defined, unbiased, legitimized, and transparent autonomous vehicle safety assessment framework. By the way, these are few words is coming from Greg Stevens when we talk about these. And so clearly defined, meaning the consensus building approach from the community, we need to know, we need to have a clear target so that autonomous vehicle companies is not just, iteratively, endlessly looking at how we can pursue in terms of the safety performance. And we all know safety and scalability is sort of a balancing, right? So you want to balance between these two so that you can find the business case. So we will need to have a clearly defined goal in terms of what will be the acceptable safety performance. And we want to be unbiased, and so that not only just self-reported safety performance from the companies, but also from unbiased, objective, rigorous, third-party evaluation so that we provide convincing evidence to the public. And we want to have a credible agency or organization so that provide this type of service to conduct the test. And then we want to make the protocol transparent so that it can be accessed by the public as well, how we conduct this type of test. All right, so that's where Mcity safety assessment program has been really developed. So in the current Mcity safety assessment program, what we're targeting is to have an unbiased, a rigorous, transparent, and also publicly accessible safety evaluation program for autonomous vehicles. And so the program itself has two parts. One is we want to be able to assess the basic behavior competency. And this is important too. We want to ensure these vehicles can maneuver with some basic behavior competency. For example, they can follow other vehicles, they can do the left turns, they can merge into the freeway, and things like that. It's very much similar to the driver's license test. We want to have a basic competency ensured before this vehicle being deployed. And by the way, I think that's important, although most of the autonomous vehicle company will say, okay, we can deploy, and we obviously have this basic behavior competency, but you will be amazed in some of the situations they will fail. And so to have a rigorous driver licensing test is important. The second part is we want to be able to assess in terms of the statistical performance of these autonomous vehicles in terms of safety, particularly in a sort of an unknown environment, right? So when you want to deploy these vehicles in a new city, and you want to know what will be the safety performance before these vehicles being deployed, particularly in a larger scale. And so that's where we're going to do what we call driving intelligence tests. In this case, we're looking at a large-scale deployment so that we can statistically estimate in terms of the safety performance of these vehicles. So we have these two tests. One is the driver license test, and one is the driving intelligence test. And then for our test, we treat autonomous vehicle as a black box. We're not really interested to know in terms of internally what the vehicle the components are. We really look at in terms of the vehicle as a whole, and then looking at how these vehicles behave in the environment. So that's also what we want to do is we propose this what we call the paradigm shift from the functional safety I was just talking about into more behavioral safety. And then just to follow in terms of how these functional safety, so TIF being defined, here we define the behavior safety as the absence of unreasonable risk due to hazard resulting from AVs, autonomous vehicles, unsafe behavior response to, and also interaction with the traffic environment. So in this case, in our definition, so what you will see from the figure is we're not really looking at in terms of this individual vehicles hardware failure or functional insufficiency. We assume all of these have no problem. And now what we trying to look at, we look at how this vehicle behaves. For example, I'll give you one example. When let's say the autonomous vehicle is driving on the freeway, and then there's another human-driven vehicle, emerging from the on-ramp. Now, for this vehicle, autonomous vehicle on the freeway, they have three choices, behavior choices. One is they can accelerate, pass by the ramp, and then so the on-ramp vehicle merged behind it, behind the autonomous vehicle. Second, they can slow down, allow the vehicle merge in front of the autonomous vehicle. Third, and this autonomous vehicle can do the lane change to the left, and so that they can avoid the human-driven vehicle to merge in. So there are three different behavioral choices, and assuming all of the functional safety of the function of the hardware and software behave correctly, and then what are the choices they make. And different choices, the behavioral choices they make also have different implications in terms of safety performance. They may impact other vehicles within the traffic flow as well. Not only, so I would say in addition to the safety of the autonomous vehicle. So the two key aspects we're looking at in terms of the safety, the decision making of the autonomous vehicle. One is how do they react to other vehicles, and the other one is how they interact with other vehicles. Okay, so I think that with behavioral safety, what we emphasize is not the vehicle-centric. Rather, we're looking at holistically in terms of traffic environment, right? So we want to be able to provide a traffic environment so that we can evaluate the safety performance of autonomous vehicle, particularly when they are being deployed in a larger scale. Here we assume the autonomous vehicle fully functional and free of malfunctions. And then the rest of it, I'm going to go quicker. And if you have interest, you can certainly look into the papers. And I think I basically present the argument why we need a behavioral safety assessment program and how Mcity's behavioral safety assessment program really can fulfill this need. And so the rest of it is really the details in terms of how we're going to do that. And so if we want to develop these, we will need to overcome two basic challenges. One is really because this is a black box to us, right? So the failures is really unpredictable. So it will really require a holistic environment rather than just extreme case testing. Just not only just scenario-based approach, it's just not sufficient. It's important, but not sufficient. Second is because the test environment is complex, and so not only complex, but also safety critical event are low probability. So it doesn't really appear that often. So that requires both a more realistic testing environment, but also have an efficient mechanism to generate these safety critical situations. And so we're trying to overcome these situations by looking at, for one, has a machine learning-based approach to generate the traffic environment, and so that they can realistically reflect in terms of what's happening in the real world, particularly in combination of some of the softwares on sensor simulation and others. The other one is trying to be able to accelerate the testing process as well. And so it's not only just, you run it in these simulation models. Even in simulation, if you don't accelerate, it still take a long time to see some of the meaningful safety critical event. So we need to have a way to accelerate the generation of these safety critical situations. Then we will be able to look at in terms of both the basic behavior competency for driver licensing test, and then also the driving intelligence test to help us to assess the statistical performance, as well as helping us to discover these unknown unsafe events. And so the rest of the slides, I'm showing you some examples, but these examples will be shown by my colleague as well in the following presentation. And so this is just one example how we utilize Mcity's digital twin and also the simulation software we have developed called TerraSim to evaluate open source autonomous stack called AutoWare.universe. And just to give you maybe one example, I want to show you here. So you can see that the red vehicle is the autonomous vehicle and crossing the intersection, turning left. And opposite direction, there's a blue vehicle coming in. And then the autonomous vehicle detect that and then stopped. And then that human-driven vehicle also see that and then paused and then resume. And then they somehow resume at a similar time, and that result into a crash. And so there's, let me give you another one is, so again, the autonomous vehicle is the red vehicle doing the circling into the roundabout, and then a human-driven vehicle approach to the in the roundabout, get into the roundabout, and then did not really yield to the autonomous vehicle. And if you look into this situation as well, it's the autonomous vehicle, although the autonomous vehicle has the right of way, but they also have a capability or have the time to slow down to avoid the accident as well. And so that's something that obviously the autonomous auto-aware stack can be improved as well. And so by doing so, and if you do this in the number of runs, and particularly with our acceleration techniques, and we estimate the current autonomous auto-aware.universe, their latest open source software, is about 2,000 times higher in terms of accident rates than the average human drivers. So I'm going to skip this in terms of the mixed reality testing. You've seen these already. And then the last thing I want to mention is that we are particularly excited about this partnership together with Matter, who is a nonprofit organization. And then together with University of Michigan, we are a public institution. This partnership will help us to build this digital proving ground, and then has the credibility to offer this as a service to autonomous vehicle companies, but also to the government agency as an unbiased third-party testing organization. And we'll be really interested to work with Mcity members and the private industry to work with us to provide the tools for us to do this test. For example, the sensor simulation, we're really interested to work with NVIDIA, look at their Omniverse and Cosmos tools to combine with the TerraSim simulation we have, and also combine with our physical test track, and to help us to develop this digital proving ground as a service. And as Greg mentioned in the morning, most of the research we have done at Mcity, we are going forward with the open source mode. And so as a Mcity member, you probably all received the recent paper we wrote on the Mcity Safety Assessment Program on behavioral safety testing. The source code will be open source. The paper will be available online. And then also the simulation model we developed, the paper is already online, and the open source source code is available already. So the last thing I want to mention before I end is to acknowledge the funding support for the safety assessment program we have developed from the US DOT, the City of Detroit ADS deployment project, the Center for Connected Automated Transportation, the regional UTC, and obviously the National Science Foundation for the Mcity 2.0 project. So with that, I'm going to stop here, and I will answer questions if you may have. Yeah, go ahead, Paul.
All right. Oh, here it is. I think you've done a good job of laying out the problem. Let me add one other complexity and see how you react to it. Right? There's two pieces to this. There is the factual data on the crash risk of these vehicles. And then there's the public perception of the problem, right? And the challenge is that when you look at the literature on human risk perception, people overestimate the risk of things for which they have no exposure. So if you look at the surveys on what do people think about, automated vehicles, and if you cut the data with who's actually ridden or driven one and who has not, the large fraction of the public has never driven or ridden one of these vehicles, so they really don't know what it's like. And let me add one sort of personal perspective. Right? I was in Arizona, and I had a chance to ride in a robo-taxi. My perspective of what an automated vehicle can do was sharply changed by that experience. And so the question is, how do we get the public perception to change, not just the facts of an evaluation?
That's a great question that I don't know how to answer. And because I'm an engineer, and so what we still working. What we like to do to be able to provide the factual data so that we can present this to the public from a third party unbiased organization. And then how this will really impact in terms of people's opinion. And I don't know what's the best way to proceed in terms of either public education or outreach, some sort of outreach event and things we can do to improve people's perception on autonomous vehicle safety performance. And there's a number of things that obviously can be done. But here, really, for Mcity and for the safety assessment program, really the focus is to be able to provide concrete evidence in terms of the safety performance. Any other questions? Yeah, go ahead, Michael.
Great presentation and really fascinating. And I'm curious, you described a little bit in the paper, but I'm curious just to hear more from you on sort of the list of behaviors that you're testing against and how you develop that list. And is that something that will just continue to grow as you have more data of crash data, or how you're thinking of the actual like scenario list that you're testing against?
Yeah, so that great question. Actually, that's probably the one what I want to say is we're not really bounded by a list of scenarios. You know, I know all of the autonomous vehicle company has, you know, a tremendous, you know, list in terms of the scenarios. But what we find out is particularly for driving intelligence tests in terms of estimating the deployment, the safety performance during deployment, scenario testing is not sufficient. Even you have 1 million scenarios, you will find that, you know, there's a number of uncovered cases. And it's very difficult to replicate all of the scenarios in just by a list. And so particularly for these unknown, unsafe type of events, right? So you don't know whether your vehicle will perform safely in certain type of situations. Even that situation is a normal situation. And remember, one of the struggles for autonomous vehicle is the sort of the challenge for autonomous vehicle is all of these algorithms is trained by the discrete samples, right? So, you know, I collect this piece of data and then you collect second piece of data. You know, we have hours of data, but all of the data is discretized. And so you can't guarantee you have a full continuous coverage of the spatial temporal space, which is autonomous vehicle going to be operate in. So there are always cases that it may perform, you know, unsafely even under normal conditions. So in this, because of this, there's no way you can test those in, you know, just you know, fixed number of scenarios, and you can only discover those from a continuous, you know, traffic environment, and then through some sort of acceleration technique to uncover these type of cases. For example, I'll give you another case for the, you know, just for the open source all-aware universe. And all-aware universe also have problems when they, you know, sort of circling on a roundabout, and if there's a particular location for autonomous, for a human-driven vehicle approaching to the roundabout, and then this vehicle will just suddenly stop and not moving. And it's, it's a normal scenario. It's the human driver will never experience those. Will never have problem with those, but the autonomous stack has those in a particular position. And so those are the so-called unknown, unsafe situations we like to discover through this continuous, running within the simulation environment to uncover those.
A great answer, and it seems like it's a combination of you have some scenario lists or where you're starting, but then it is sort of a continual evolution within a simulation. I think one element connecting back to sort of the public perception piece, I think would be interesting is if people could submit scenarios or things they're concerned with or have a vision of something happening, because in a similar sense that sort of the unknown and feeds back to the public and could be an interesting sort of element to add.
Exactly.
Yeah.
Exactly. All right. Thank you very much.